Ask yourself, what does an everyday smartphone have in common with a hybrid electric car, a wind turbine, industrial robotics, an MRI machine? All these machines, and many others used in telecommunications, transportation, healthcare, defence, and renewable energy, rely on magnets for their complex functionality. While heavy ferrite magnets dominated industry for decades, a new generation of permanent magnets, incorporating rare earths, has become increasingly popular. Although 3 times lighter than ferrite magnets, permanent magnets offer 10 times the power, making them ideal components within electric motors. This has allowed everyday devices to be miniaturized while providing higher efficiency and superior performance. Just imagine a refrigerator that uses a safer, quieter magnetocaloric electric motor to eliminate the need for harmful gases and high electricity bills. This ability to offer a clean solution to the consumer puts rare earths at the forefront of the renewable energy movement. So, what are rare earths? These 17 elements are not technically rare, but are often difficult to economically extract, making opportunities for profitable and sustainable rare earths mining especially limited. However, Hastings Technology Metals has discovered a significant deposit of rare earths, rich in neodymium and praseodymium, in the Gascoyne region of Western Australia. The Yangibana project hosts JORC resources totalling over 17 million tonnes at 1.27% total rare earth oxides, including 0.41% neodymium and praseodymium oxides. The total rare earth oxides contains an average of 32% neodymium and praseodymium content, with some areas up to 43%. Both elements are critical inputs within rare earths permanent magnets, and this extraordinary discovery at Yangibana has led Hastings to invest in a processing plant, the first of its kind in Australia. Following a pre-feasibility study investigating the suitability of a wide range of processing techniques, the Yangibana processing flowsheet was developed by the Hastings technical team in conjunction with industry consultants. The proposed production plant comprises a system of beneficiation and hydrometallurgical extraction to ultimately deliver a valuable mixed rare earths carbonate product. This flowsheet was then commercially trialled under a pilot test scenario at 2 leading commercial test work facilities in Australia, where pilot plants for the beneficiation and hydrometallurgical phases were assembled. At ALS Metallurgy in Perth, Western Australia, the beneficiation pilot plant consisted of milling, rougher flotation, regrind and cleaner flotation stages. The plant ran at a rate of 150 kilograms per hour for 24 hours per day, continuously over 8 days. The flotation circuit selectively concentrated the rare earths-bearing mineral monazite into a final product, bearing a total rare earth oxides content 20 times higher than the original run-of-mine ore. Optimised flotation circuit chemistry in the adjacent laboratory has allowed for continual improvements, with the circuit able to achieve over 80% total rare earth oxides recovery at a final concentrate grade of 25% total rare earth oxides. Over 300 kilograms of flotation concentrate were ultimately generated at ALS. The concentrate was transported to the hydrometallurgy pilot plant at ANSTO Minerals, a business unit of the Australian Nuclear Science and Technology Organisation, located in Lucas Heights, near Sydney, New South Wales. It was treated at a rate of 3.5 kilograms per hour for 24 hours a day. The pilot plant comprised 3 phases: acid bake, water leach and impurity removal, and mixed rare earths carbonate product precipitation. All 3 phases achieved or exceeded the operational process parameters set by the initial Yangibana processing flowsheet, with rare earths recoveries at or above 94% for water leach, 95% for impurity removal, and 98.5% for carbonate precipitation. The major product impurities of manganese, iron, thorium and uranium were removed or controlled within acceptable product range. Using commercially available equipment and proprietary reagents and incorporating standard industry practices, both the beneficiation and hydrometallurgy pilot plants validated years of work by Hastings' technical team. The rigorous process revealed the average neodymium and praseodymium content of the original Yangibana ore to be higher than comparable rare earths deposits elsewhere in the world. These findings successfully demonstrated the financial viability of the Yangibana process flowsheet and proposed scale-up to commercial production. An independent team of specialist equipment vendors completed test work on samples generated during the pilot plant operations to size and select equipment for key solid-liquid separation steps. The collection of data from the ALS and ANSTO pilot plants were critical steps in the definitive feasibility study process. Over 50 kilograms of high-purity mixed rare earths carbonate produced from the pilot plant will be presented to potential customers as proof of Hastings' ability to produce a premium rare earth product. A dedicated team of professionals with prior rare earths production experience is working to launch production at Yangibana by the second half of 2019. This schedule aligns with a series of exciting announcements made recently by governments and corporations dedicated to clean and renewable energy solutions. In the wake of the 2015 Paris Agreement, global stakeholders have acted to reduce smog and tackle climate change by phasing out internal combustion engines. The race is now on to embrace fully electric or hybrid electric vehicles production targets. The rising international demand for electrical motor components derived from rare earths puts Hastings in an enviable strategic position. With more than 90% of the Yangibana tenement still to be explored, Hastings Technology Metals is set to play a major part in a sustainable, energy-efficient future.